Tubular receiver minimalism. Open bolt operation simplified. Stamped steel components prevalent. Welded seams, inconsistent penetration. Receiver diameter approximate. Wall thickness, variable tolerances. Mild steel composition unspecified. Phosphate surface treatment rudimentary. Heat treatment largely omitted. Bolt mass calculations approximate. Recoil spring wire inconsistent. Spring temper uncontrolled. Forward sear engagement crude. Sear geometry angular misalignment. Trigger, linkage simplified bars. Trigger pull excessive variance. Safety notch unreliable engagement. Drop discharge incidents documented. Magazine housing side mounted. Welded magazine collar thin. Feed angle shallow geometry. Double column single feed. Magazine lips fragile steel. Lip deformation common issue. Follower stamping uneven surfaces. Follower tilt frequent. Spring compression inconsistent rates. Ammunition sensitivity significant. Cartridge pressure variation tolerated. Chamber dimensions generous allowances. Chamber reaming inconsistent depth. Headspace uncontrolled production. Extractor claw brittle failures. Extractor spring weak tension. Ejector fixed pin welded. Ejector alignment inconsistent. Ejection port oversized opening. Debris ingress likely. Dust tolerance poor. Mud tolerance unacceptable. Open receiver vulnerabilities obvious. Bolt travel exposed. Bolt over travel uncontrolled. Rear cap threaded poorly. Thread pitch coarse, cap loosening common. Stock attachment minimal welds. Wire stock flexural weakness. Butt plate absent. Shoulder contact unstable. Ergonomics disregarded entirely. Sight system rudimentary. Front sight brazed block. Rear sight fixed notch. Sight radius short. Zeroing in practical field. Manufacturing drawings incomplete. Tolerances verbally communicated. Factory tooling improvised. Lathe time minimized. Stamping dies unrefined. Die wear unchecked. Quality inspection cursory. Gauge usage limited. Serial numbering inconsistent. Batch traceability impossible. Interchangeability partial success. Bolt fitting manual adjustment. Receiver straightness variable. Bore alignment uncertain. Barrel manufacture subcontracted widely. Barrel steel heterogeneous sources. Rifling broach worn. Rifling depth inconsistent. Twist rate approximate. Crown finishing omitted. Muzzle protection absent. Flash signature prominent. Sound signature sharp. Suppressor concepts rejected. MKI suppressor, trials limited. Integral suppressor, complexity excessive. Cost targets absolute priority. Unit cost minimized ruthlessly. Labor skill minimized deliberately, training time negligible. Assembly sequence simplified steps. Welding fixtures crude jigs. Jig alignment drifted. Production speed prioritized. Defect acceptance broadened. Functional definition minimal. Accuracy expectations abandoned. Effective range theoretical. Burst dispersion extreme. Controllability poor ergonomics. Rate of fire variable. Bolt mass fluctuation driver. Spring fatigue rapid. Cyclic rate increased. Cook-off risk low. Runaway fire incidents recorded. Sear wear accelerated. Hardened sear absent. Case studies alarming. Troop confidence diminished. Accidental discharges frequent. Drop safety non-existent. Transport handling dangerous. Loaded carry discouraged. Empty chamber doctrine recommended. Combat readiness reduced. Operational doctrine adjusted. Weapon feared infinitely. Enemy threat secondary concern. Reports suppressed internally. Official acceptance maintained. Wartime desperation overriding. Resource scarcity extreme. Machinery bomb damaged. Skilled labor evacuated. Time pressure relentless. Air threat persistent. Replacement urgency severe. Paratroop supply needs urgent. Airdrop packaging simplified. Cosmoline application minimal. Packaging crates lightweight. Parachute bundles compact. Intended disposal acceptance. Expendable philosophy explicit. Post-use discard planned. Maintenance expectations minimal. Spare parts non-existent. Field repair discouraged. Manuals abbreviated. Illustrations crude. Training pamphlets sparse. User adaptation required. Improvised fixes common. Tape retention methods used. Magazine tuning field expedients. Feed lips bent manually. Spring stretching attempted. lubrication improvised oils, cold weather malfunctions, congealed lubricants hindered, hot weather wear accelerated, sand abrasion severe, receiver galling observed, bolt scoring increased friction, corrosion resistance inadequate, phosphate thin coating, storage rust common, warehouse humidity uncontrolled, sea transit corrosion high, salt exposure damaging, barrel pitting frequent, accuracy degradation rapid, life expectancy short, rounds count minimal, mean rounds between failure low, statistical tracking absent, feedback loops ignored, design revision slow, MK2 simplification continued, machining further reduced, sights further degraded, stock even simpler, lessons partially integrated, safety issues persisted, accidental fire continued, institutional acceptance hardened, risk calculus shifted, human cost accepted. Command priorities strategic, weapon function sufficient, political oversight minimal, parliamentary scrutiny limited, secrecy maintained. Post-war evaluations critical, veteran testimonies harsh, archival reports reveal, engineering compromises documented, design intent clarified, disposable concept validated, ethical considerations secondary, logistical success measured, occupied Europe saturation achieved, resistance armament widespread, failure rates tolerated, attrition expected, training assumed minimal, weapon familiarity low, user survivability uncertain, strategic outcomes prioritized, industrial improvisation exemplified, engineering orthodoxy abandoned, standards committees bypassed, documentation gaps permanent, historical judgment complex, design ugliness assumptions functional, purpose fulfilled narrowly, legacy controversial, lessons institutionalized later, post-war safety reforms, manufacturing discipline restored, standards reimposed, expendable philosophy retired, historical record complete,